Hello my dear students, good afternoon. Now we will continue with the preparations of alcohols. Actually previously what we discussed I won't repeat. So now reduction of aldehydes and ketones. Okay, so what happens in this? Reduction of aldehydes and ketones means RCHO, RC double bond OH. This is aldehyde actually. If instead of R, if you have hydrogen, this is called formaldehyde. What is this? Formaldehyde or methanol. What is that? Methanol. Methanol on reduction. On what? Reduction and reducing agents are what? I'll tell you. So on reduction it turns to methanol. How many carbons you have? Those many carbons you will have in same alcohol. So here in formaldehyde one carbon you have, so methanol. So reduction means what? Addition of hydrogen. So what happens here if this bond breaks? Here hydrogen and here hydrogen. Okay, so here bond broken, here double bond, and H here and H here, CH3OH. So that's called reduction. And here reduction means addition of hydrogens, you know already. And one more, if you see RC double bond OH, when you are taking this is on reduction. On what? Reduction. You will get RCH2. So one more hydrogen will add here and here one. So RCH2OH. RCH2OH you are having. So one H here, one H here. Getting what I am saying? So formaldehyde on reduction you are getting super primary. And any other aldehydes on reduction you are getting primary alcohol. And something else like ketone RC double bond OR. Okay, RC double bond OR. Then what happens by reduction? On reduction, same story, you will get R, C, H and OH and R. So what happened? Addition of hydrogen. So here one hydrogen and here one hydrogen. Addition of hydrogen happened. So on reduction of, this is ketone actually, ketone and giving secondary alcohol. Ketones on reduction, secondary alcohol. Aldehydes on reduction, primary alcohols. Formaldehyde on reduction, you are having methanol. Difference understanding? Now let's see the reagents used here. What are the reagents? What are the reducing agents? Reducing agents used are nickel or nickel by H2 or palladium by H2 or platinum by H2, then nickel by H2, like that we use. Okay, zinc amalgam by HCl, zinc amalgam by HCl. These are reducing agents. And one more reducing agents like NaBH4 and LiAlH4. LiAlH4. These all are the reducing agents. So these are metal with H2, hydrogenation. Okay, adsorption, nickel surface if you take, this is the nickel surface. On this nickel surface, hydrogen gas we will send. Okay, on surface these hydrogen atoms will absorb like this. Okay, these hydrogen atoms will approach this particular double bonded carbons. Then these hydrogen, this hydrogen here and this hydrogen here. Okay, but one more important thing is, if we use metal with H2, wherever the unsaturation is there, that converted to saturation. This is very important thing. Getting what I am saying? So when we use metal with hydrogen as reducing agents, wherever you have a double bond or triple bond, they convert to saturated. If triple bond, first converted to double bond converted to single bond. Because hydrogen atoms we are adding at double bonded carbons or not. Double bond is present between two carbons. So two hydrogens we are adding at two carbons. Getting? So these are very important. So what I said right now, if we use metal reducing agent, then it reduces all types of bonds. Means wherever the unsaturation, where reduction takes place, tell me, wherever the double bond is there that converts double bond, means by breaking pi bond, two hydrogens will add, that is called reduction or not, or else removal of oxygen. But here we are preparing alcohols, means double bond must convert into single bond. Means C double bond O must convert into COH. C single bonded OH. So this is clarity. So if I am using this CH3, CH double bond CH and CH double bond O. If I am using nickel by H2, means I am adding H2 in presence of nickel, like this if they given, what is the final product means? Listen carefully. Here this CC double bond is there and CO double bond is there. This CO double bond is there. So here one H2 molecule will add by breaking the pi bond, and here one H2 molecule will add as two hydrogens. Because those hydrogen gas, that hydrogen gas absorbed on surface of nickel. That is called adsorption process. Adsorption. AD. Okay. Now, what is the final product here? The final product is CH3 and CH2 and CH2 and CH2OH. This is the product. So, wherever you have a double bond, the double bond broken and that convert into single bond, and double bond convert into single bond. Correct? But same for this CH3, CH, double bond CH and CH, double bond O. If I am using LiAlH4 or else NaBH4, lithium aluminum hydride or NaBH4, if we use as a reducing agent, remember, this is very important point for you. These reducing agents, either any one, LiLH4 or NaBH4, if used as reducing agents, they reduce only functional groups. Understanding? So this is very important for us. So what is the final product here? CH3 and CH and double bond CH and CH2 excuse me, OH. So what happened? This double bond O, this pi bond broken, here hydrogen and here hydrogen. So LiAlH4 and NaBH4 will not reduce like C double bond C or C triple bond C. So double bonded carbons and triple bonded carbons will not be reduced by using this LiAlH4 or NaBH4. This is a very important point for you. Okay, so important note actually. So what is the difference between these two reactions? This one and this one. What is the difference you observe? Same, I used reducing agent, here also I use reducing agent. But when I use metal with hydrogen, wherever you have unsaturation, that converted into saturated. This C double bond C also reduced and C double bond O also reduced. But in this case, C double bond C was not reduced. Selective reduction takes place when we use this. So what is the final conclusion there? LiAlH4 and NaBH4. NaBH4 will reduce only functional groups. What groups? Functional groups. Functional groups like aldehydes, ketones, okay, carboxylic acid, like that. They'll reduce. C double bond ONH2, like that. So only functional groups who have unsaturation, those only gets reduced if you use this LiAlH4 and NaBH4. But for LiAlH4 there is one exceptional case, only one. What is that, you know? Actually LiAlH, NaBH4 is pakka. NaBH4 never reduce that C double bond C and C triple bond C. But you have to write these all these things. Okay, so this is very correct, absolutely correct. NaBH4 will never reduce C double bond C and C triple bond C. But for LiAlH4 there is one small exceptional case. Do you know what is that? Actually, just now I was given one thing. If CH3, CH, double bond CH and CH double bond O, if I using LiAlH4 as reducing agent, lithium aluminum hydride, the product is without reduction of this C double bond C, this C double bond O will undergo reduction. Certainly the product is CH3 and CH double bond CH and CH2OH is the product. Remember, this is very important for us. Okay, so here OH you have. Okay, but if you use same LiAlH4, if this double bonded carbon attached with phenyl group, attached with what? Phenyl group instead of this methyl, then what happens? Reduction happens. That C double bond C also will undergo reduction. When, what is the condition? That double bonded carbons, what you have, that alkene or alkyne, must have phenyl group. That means instead of methyl, I will write this C6H5 and CH double bond CH and CHO I can write actually. Okay, but for your understanding clearly, I am just writing CH double bond O. Okay, so now what happens? See the difference, interesting thing. Here, the C double bond C was not reduced because these double bonded carbons don't have phenyl. But if this CH double bonded carbon has phenyl, only phenyl, because reactivity increases, then what happens, you know, this will undergo reduction and this will undergo reduction. Certainly our final product is now C6H5 and CH2 and CH2 and CH2OH. Understanding? This becomes CH2, this becomes CH2 and CH2OH. Reduction happened. See the difference between these two reactions so that you can have clarity. What I am saying? LiAlH4 also reduce C double bond C. But when? If there is a condition. If that double bonded carbon, what is that? Double bonded carbon has phenyl group. What group? Phenyl group. Otherwise, LiAlH4 will not reduce any C double bond C and C triple bond C. What is the condition I told? What is the condition? This LiAlH4 and NaBH4, LiAlH4 and NaBH4 will never reduce C double bond C, C triple bond C and C triple bond N also. This also cannot be reduced. C triple bond N also cannot be. Okay. So cannot be reduced. Reduced by what? LiAlH4 and NaBH4. The most important thing in this class. Please everyone note down this. But only one important thing for LiAlH4, only one exceptional thing. If the double bonded carbon has phenyl, phenyl means, do you remember? Benzene ring, C6H5, this one. Like this. If there for double bonded carbon, then that will reduce. What will reduce? Not benzene ring. this C double bond C will reduce. So this is very important. So what I'll give you the final conclusion. NaBH4, no exceptional cases. NaBH4 will never reduce C double bond C. Okay? Never reduce C double bond C when functional group is there. Getting what I'm saying? But LiAlH4 also will not reduce C double bond C and C triple bond C if functional group is present. LiAlH4 and NaBH4 always reduces functional group. Okay, reduction of C double bond C, C triple bond C, C triple bond and won't happen. But LiAlH4 reduce C double bond C along with functional group. But when the double bonded carbon has phenyl ring. Okay, over sir now. See this. Suppose C6H5. Now I have this. Okay, double bonded O I have and double bond E have. And if I'm using this, reducing agents like LiAlH4, then what is the product? Here there is no phenyl ring. Are you thinking this is phenyl ring? No. Phenyl ring means 3 double bonds. Benzene ring, but this is cyclohexenone. Cyclohex, if this is not there, double bond oxygen is not there, cyclohexenone. This is on treating. Only functional group will undergo reduction, I told now. So C double bond O only will undergo reduction. This C double bond C will not be effect if I use LiAlH4 or else if I use NaBH4. Now the final product is now this C6 H4 H11 lighter will come and here OH and double bond remains. But the same reaction if I am using this double bond and double bonded oxygen and H2 in presence of nickel given or platinum given, H2 in presence of palladium given, same. Now what will be the product? Means double bond C double bond C also undergo reduction. Now this is the product. What happened? Here also one hydrogen and here also one hydrogen came. So instead of double bond, instead of this pi bond, 2 hydrogens was added. That is reduction. Difference you understood? See the difference. If you use LiAlH4 and NaBH4, what is the product? And if I use metal with hydrogen, hydrogenation with metal, what happens? Okay. So these are very, very important reactions. So you must follow and write down everything. So next is next one. I don't know what is the number exactly, how many preparations we discussed, but next preparation is hydrolysis. Hydrolysis of what? Mr. Alkyl halides. Alkyl halides. Actually, I was given this already. Yes, if you use aqueous KOH, what is the product? CH3, CH2, CH3, CH2, some Cl. I am using Mr. aqueous KOH. Do you remember? Monohalo, dihalo, trihalo. When treated with aqueous KOH, what are the products I told? Do you remember? So monohalo alcohols. So the product is CH3 and CH2 and OH you are having plus KCl. Do you remember? If the dihalo compound, geminal if you take an aldehydes is the product, dihalogen compounds. And geminal instead, that geminal if the double 2 chlorines are at middle carbon ketone. Do you remember this? Very important. That's why I'm because in aldehydes preparations I will say this CH3CH and Cl and Cl. When treated with aqueous KOH, what is the product? And CH3, C, Cl and Cl and CH3. When I am treating with aqueous KOH, what is the product? Sir, in alcohols preparation, why you are talking about this? In our next chapter, I will say these only. So when common reactions came, we have to remember by comparing. So if I have these 2 chlorines like this at the geminal positions, gem at terminal carbon, gem at middle carbon, Middle means not exactly middle, at any middle carbon. Then what is the difference here? Here you are first having alcohol only, diol. That means the product is here for this CH3 and CH, and here OH and here OH. And finally this diol and losing water molecule and minus H2O, then the final product is CH3 CH double bond O. Whereas here first diol only, like CH3 C and OH and OH and CH3. It's like one of the alcohol preparation only. It's not time wasting. Don't think like that. So now what happens by losing water molecule? Minus H2, H2O will go. So minus H2. Then our product is like CH3, C double bond O, CH3. This is the final product. Got it, sir? So very important, you must know all these things. If it is vicinal you must know, because alcohol is only final product. CH2Cl and CH2Cl, when you are treating with aqueous KOH and the product is CH2OH and CH2OH. Of course 2 moles we have to take everywhere, because 2 chlorines are there, no? 2 moles. Monochloro, so 1 more is enough, because 1 chlorine replaced by OH. Got it? So this diol preparation, diol. So do you know ethylene glycol? Yes, this one, ethylene glycol, CH2OH single bond, CH2OH. Do you remember glycerol formula? To prepare glycerol, what required? They'll ask you. So CH2Cl, CH2Cl, CHCl and CH2Cl. This when react with Mr. 3 moles of aqueous KOH, then glycerol will have or not. So what is the reactant required? They'll ask you. Maybe. So glycerol preparation. To know what is glycerol formula, you must know. So write down all these things, very important. Now this is hydrolysis only. Why we call hydrolysis? Do you know? OH is adding in presence of water. Hydrolysis. Got it? Now hydrolysis of alkenes. Hydrolysis of what's the alkenes we will discuss now. Okay. So hydrolysis of alkyl halide, why completed fast? We know this already. So hydrolysis of alkenes. This also you know maybe, because addition of water to alkene. Addition of water H2O in presence of acid. Acid hydrolysis. Why acid? Acid donate H plus ions first. Acid will initiate the reaction actually first. So addition of water in presence of acid to alkene. To whom? Alkene. So this is very important. So you know this happens by Markovnikov rule if we are not using any peroxide. CH2 double bond CH2. If I am using water, so in presence of sulfuric acid H2SO4 acid, so this provide H plus actually. Now the product is CH3 and CH2OH. This happens. Okay, this reaction happens in 3-step mechanism. One is step 1. Okay. So, step 1. What is the step 1? Protonation. Protonation on alkene. This is the first step for this. What happens here, understood? So, I'll tell you in mechanism. Actually, water means H plus and OH minus. Actually, that H plus came from this H2SO4. First H plus will come. Do you remember like electromeric effect? Like that. So now this CH2 double bond CH2, when I am adding this H plus. Now what happens? Both carbons are same. So double bond can migrate towards any one of the carbon. Certainly this H plus can add here. No? H plus will add here. Correct? Because here coming negative charge. So H plus will come over here. Certainly here you are having CH2 plus and single bond and CH3, right? So don't worry. So this I got. Now come to step 2. Now this I am writing again this as CH3 and CH2 plus. So no sir, positive charge left side, don't say like that. This CH3 and CH2 plus. Otherwise I will write like that only. CH2 plus and CH3. And for this I am adding water. So water here act as nucleophile. What is this? Nucleophile. So what is step 2? Step 2 is attacking of nucleophile. Attacking of nucleophile. Water is nucleophile or not? Because neutral nucleophile example I was given. Because water has 2 lone pairs. Of course one lone pair only will donate. Okay. So number of dative bonds can be formed by one particular atom is maximum only one. Even 3 lone pairs are there. Understanding? So this is very important. So water will add on this positive carbon. So this lone pair will donate it to this positive carbon. Certainly what happens here? CH2 and CH3, and here you have OH2 plus on oxygen positive charge. Why positive charge on oxygen? Donated lone pair to this carbon because this is positive carbon. Can you guess what will be the step 3? Step 3 is deprotonation. But deprotonation from where? Here. Understanding? So deprotonation means removal of proton. Removal of H plus. Okay. So what happens from this now? CH2 and OH2 plus and CH3, and from this minus H plus. From here now you will get and CH2 OH and single bond CH3. This happens. So this is about hydrolysis of Mr. Alkenes. Hydrolysis of what? Alkenes. These 3 steps you must know. Protonation on alkene, first step, and second step is attacking of nucleophile, and third step you have no need to look at this, just remove H plus from here. So CH3 CH2 OH, that's it. Getting what I'm saying? So these 3 steps, have a screenshot and write down along with that reaction. Doing that? Okay. Next, if instead of Mr. H plus means H2SO4 instead some other given like deuterium D plus given, then what is the product? Okay, so here I'll give that reaction. What is that reaction? Instead of this H plus, like this given CH2 double bond CH2, when given water and D plus given, few people what they will write, whatever they given, water means I know this is H plus and OH minus, so they will do only one thing, that is CH2 and CH2, and here one carbon has H and one carbon has OH, that's it. Oh, no, this is absolutely wrong. So here protonation will be done by Mr. Acid who donated. So H plus hydronium ion, deuterium ion will be donor here. So D plus will add on this first, any one of the carbon if this migrates, because both carbons are same here. Understood? So D plus will add. Now negative species, water will add on this. So OH. So here hydrogen, no. Here D will come. So D and OH like this. This is very, very important. Suppose here CH3CH double bond CH2. I am adding water in presence of D plus. Now what happens? Same story. This will migrate here. So here both directions are not same, because according to Marconikov's rule, negative species means nucleophile. Here nucleophile water or else OH minus you can consider. So negative species will act to the double bonded carbon which have less number of hydrogens. Means OH will come here, pakka. So H plus will come here, no, D plus will come here because on arrow what they given, D plus. So finally the product is now CH3 and CH and here OH and CH2D here. Different understanding? So these have to migrate towards this carbon, arrow mark towards this carbon, pakka. Because here positive charge is more stable, secondary. Getting what I am saying? So these pi electrons must move towards double bonded carbon with more number of hydrogens. I told you that also. Always migration will be like that in absence of peroxide. If peroxide is there, anti-Marconi compound. But it's a suppose here given like this CH3 and CH double bond CH2 given water in presence of H plus given like this H plus or H2O given. Now very simple, according no peroxide, so according to Marconi compound reaction takes place. That means this will migrate over here, so H plus here and OH minus here. So the final product is according to Marconi rule, negative species will act to the double bonded carbon which have less number of hydrogens. So CH3 and CH and OH and CH2H. So this H plus what was that? Oh sorry. Yeah, correct only no? Negative charge will be, so H plus will add on this and OH minus will add on this according to Marconi rule. If you use peroxide, then what happens? If you use peroxide, OH here, H here, that's it. You know all these things. Okay, even 1 to hydride shift and 1 to methyl shift, do you remember? Those also happen in this. Suppose here given like this. Okay, right or not? Okay, next we have to take one example here. If we use some different one like in which the rearrangement takes place. So as I was given in previous CH3 and CH3 and H and CH double bond CH2. For this, if I am adding water in presence of H plus, so first what happens? H plus pakka will add on this carbon. That for sure. Positive charge here. Secondary. Hydrogen will migrate. Tertiary carbocation. You are following what I am saying? Migrate over here. This H plus will add here. So positive charge in this carbon. And here positive charge is second. So hydride shift happens here. So OH will come over here. Do you remember that? So what will be the product here finally? CH3 and C and CH3. Here you will get OH. At this carbon you will get OH. And here you are having Mr. CH2 and CH3 like this. This is what shift? Due to 1 to hydride shift. I was given this in previous. Please recap all these things. And one more thing, a few more preparations I'll explain, like hydroboration and oxymercuration and some other fermentation process, all those in our next class. So that preparations will, excuse me, we will complete preparations by tomorrow. Thank you.